All right. Okay. It's recording. So, a lot of people are having trouble with the homework. And so I thought that I might do, or at least try to do mostly today, what Huddle didn't do, which was to kind of do type checking as he went along. Like he sort of waited. It was kind of like, the Big Bang theory of software engineering, where you build this giant system and then you start testing it. And so it would have been easier to start in the beginning when he didn't have many different language features and to show what type checking looked like there, and then to go on as he went. So if we go all the way back to chapter 3, which is the language BIMs, I thought we'd start there. And then, but maybe let's start there, but don't let me go too long because I want to go over also. Yesterday I was talking with, I think, Tim and Colton were there when I started looking at the rules in chapter 13 and realized that, isn't it 13? Yeah. Related topics it even is under. It's not even, okay. In chapter 13, I realized that his type checking rule for procedures is wrong. And was there another one? I guess I didn't really look at call closely. But anyway, we'll look at that just like last time we looked at that other error. So all right. So let's look at, let me put down my email. Let me get my oh, okay. This is, let me share my screen. So first, let me go back to, let's see, where can I find this? I tried to get this better organized. Okay, so here's BIMs, my implementation of BIMs. What's wrong with this thing? There we go. BIMs, and then I got bims.hs. Okay, so here's the first language that we had, and the two little evaluators we didn't even have at this point. Statements. I don't think. Hang on, let me close my door. All right, so I'm going to make something called BIMs type check
isn't statements like at the bottom of the screen?
Say what?
Isn't the data type statements at the bottom of the screen?
Oh, maybe it is. Yeah. All right. So now one thing is that, yeah, we don't need this for this type checking. Although those were derivations for the evaluation semantics. And we don't really need any of this. And this was even before he had variables, but we could add those. So we don't need any of this. So really, all we need is the syntax. Now, oh, he does have a variable. So I'm not sure, like, have people settled on an implementation of his type assignments? Is anyone, are you just using a list? Or are you using a function? So his E in the homework that you're supposed to be doing in chapter 13, his E, capital E, is a function from identifiers to types. And so a simple way to do this would be to say, okay, let's make so what are the types that we're going to have here? We're going to have bool. We're going to have int. And we're going to have, if we want to follow his, I mean, you know, we're going to have okay for statement. Now, I also see people send me code without this deriving EQ show thing, and that's going to just cause you nightmares trying to use your data type, because the thing will basically look like it crashed trying to tell you, is my internet okay?
Yeah.
Okay. I can't see myself moving at all on my videos. So that scares me. Okay, so we could define as simple types. Now, you know, let's make this a little bit harder. Let's do what he's doing, what you're asked to do in the homework here. And I'll leave it to you to do the other things. So he basically gets rid of the distinction, and we really don't need this paren thing. He gets rid of the distinction of A expression and B expression. So I'm going to turn A expressions into expressions, and this is like an edit that you probably should have done unless you rewrote everything. Some people showed me they had rewritten everything. And B expression just becomes expression. And so here's a language that looks like BIMS, except that we haven't separated out the A expressions and B expressions into separate types. I just want to see. You still can hear me.
Yeah.
This is so weird. Like my Zoom is unresponsive. Okay, now it's showing me again. Okay. I was like frozen. So, okay, let me go back to share screen. All right, so does everyone get this, that this is a nice, you know, this is a kind of expression, and that, but you know, like before in the assignments, we could only have int expressions. And in the if then else, this expression has to be a bool expression. So here we're actually going to accomplish something in a way with the type checking, because when you separate them into different types and you say this one's bool expression and this one is int expression, then the Haskell typing system is really doing the type checking for you. So we have types, and then we could make a type synonym for what he calls E, which is type assignment. And I don't know, it seems to me like the easiest way to do this is to just make it a string arrow types. And I can make, I can declare E0, which is going to be the empty type expression. It's an E. And I can say E0 of X is equal to just no matter what input you give it, it's going to crash until we start adding things to this thing. And so we'll say it's just an error, and we'll say, you know, type assignment error. Well, X itself is a string, so I can just put that in there. Okay. So does that seem okay to people, or did you do it with lists, or did you do it with a map?
So I did it.
You did it with a function. Okay. I mean, I kind of like this one just because, you know, he applies E to the identifier in his rules in in chapter 13. Okay. So now typing is going to be with respect to a type environment. And until we have declarations, we kind of like don't have a way to build the type environment in a kind of a way that you would do by evaluating the program. We just have to provide one. So we could say like, oh, I got to give an update function. So I got to say update with key and value. Whoops. I don't know. Usually I like to put it in a pair, but I guess I don't have to. So let's say update takes a string and then takes a type and returns a E. And so this code you've seen before. So I can say X T E is equal to lambda Y if X equals Y, then T else just apply E to Y. So does that bug anyone? Is anyone going like, hey, wait, I don't get that? I mean, it's just saying like it's a point-wise update of the function E in this case. Oh,
I
and I need to
understand.
return an E.
I understand it. The only thing that's kind of throwing me off is like the type. Should that be like types, or is like type a separate thing?
Types. Good. Thank you. Typo on my part. Type so. Okay. So it takes a string and it takes an element of this types. And then it takes an environment, one of these, type assignments. They're very similar to environments, right? Except that in this case, they don't map to the meaning of the abstraction. They map to the type of the abstraction. So anybody have any trouble with this? I mean, now I'm going to write the type checkers. Okay, so, whenever you write a recursive function on something like this, you just got to grab them all. And so I'm going to say, okay, type check E XP. And I'm going to take an E. It's going to take one of these E's. And then it's going to take an expression and it's going to return a types. And now I got to make room for all the different constructors that I had. Oh, darn it. I'm trying to set up a macro, a keyboard macro to do this. It didn't work. Oh, there it went. Okay, so I got to say, what am I going to do for X? Oh, and I got to put an E and V in here, an E in each one of these. Okay. So what am I going to do for a variable? Well, I'm just going to apply E to X, and that'll tell me the type. Now, actually, maybe we want this to go to a maybe types. And so then maybe I want this thing to do, then I just want this to return nothing in the default. Forget about the error. Did you get that? I mean, if I'm going too fast, you got to tell me. That's an int. Any number is an int. In fact, I can put an underscore there because I don't really care. And then these, I don't care about the arguments. But what can I do here? What do I have to do? So I'm going to get back two maybes. Oh, this is a just int. Oh, and I need to say here just p else e applied to y. All right, I don't know. Maybe that got a little bit confusing. Somebody say something like help. Or, yeah, this is good.
I think I'm following it personally. It makes sense so far.
Okay, good.
So the E, is that an environment or is that like?
It's a type assignment. You know, I just have it in a const. It is essentially, it is exactly like an environment.
Oh.
It's a function that maps strings to, if you look up here, the definition, it's a function that maps strings to types.
Okay, yeah, that makes sense. Thank you.
And so this one's the empty type assignment that just returns nothing. And then now the update to make it work in the maybe. Oh, okay. So I got to update works. I think update should have it has the right type. So now we're doing type check, and we take a exp. Oh, this one returns a maybe types now. So I built it into the environment to return the maybe. Now, you know, one thing that you can do here that's a little bit fancy. So you could say like, oh, I do need to know on these, the E1 and E2. And so I could say, I could do it a number of different ways. One way to do, but I have to deal with these, the possibility that one or both of these returns nothing because E1 or E2 might not be well typed. And it better be that if it's plus, that E1 and E2 are both integers. So I could say like case type check expression E1. Oh, I hate this E. I'm going to call it TA for type assignment. And how does that sound?
Sure.
I don't know. I'm messing everything up, but okay, whatever. Okay, so up here I'm okay. So TA, so I apply the type assignment to X, and that's the answer for a variable. And if it's a number construction, then we know it's an int, but we have to wrap it around the just. And then in this case, I'm going to type check the two of them, and I'm going to say, look, if they're both ints, then I say the type of this expression is int. Do I need that vertical bar there? I always, in OCaml, you need it, and otherwise, no. And any other answer is just nothing. If they're not both ints, this is not well typed. Does that make sense?
Yeah, I guess the only thing that's like kind of confusing me.
Yeah.
So in the case, the second type check, there's a T1, but did we
Oh,
need
that
to
should be
define?
T8. I'm sorry.
Okay, I'm sorry. If you
I'm
could please-
using this, I should be using the same type assignment in both of them, right? T1 came out of nowhere. And so actually, you know, molt is identical. So if I carefully name things here, E1, Jesse, you got an eagle eye today. E2, that's great. And then this one, this is identical. So now I start thinking, oh man, I ought to write a little function. So, and this one is identical. So now I start to feel like, gee, this is not good. I'm just cutting it. Whenever you're cutting and pasting the same code over and over again, you know, you probably need an abstraction to cover that. But okay, let's just avoid that for a minute. Okay, so when is an equals well formed? Well, an equals is well formed if well, you know, it's like a little tricky. I want to say something like, you know, that the type, if it was a total function, I say like the type check of TA of E1 is equal to the type check of TA with E2. But I mean, then I could say, you know, but this would be dumb because I'd be recomputing the type check, which is going to recurse through the whole thing. But I could say, and, you know, type check of TA of either one of them is not equal to nothing. Because he wants to allow equals to work on Booleans and on integers. So kind of logically, this is what I want to do. But really, what I want to do is probably something more like this. Except I want to say it's okay. In that case, in either case, it's a bool. But I can only compare two ints or two bools. So I got to say here, bool, bool. And otherwise, it's nothing. No matter what, the type of an equals is a bool. But the type of the arguments could be 2 ints. You could say 7 equals 9. And then that would be false. Or 7 equals 7. Or you could say true equals false. That would be false. You see? So that one's a little bit different. So now I'm looking at this and I'm going like, geez, I really, because now this one's going to be identical, except that to this, except I'm looking for bools. So like greater than.
Would we need another case that's similar to the
In
one
which
that
one?
returns just int, but it would return just bool?
Oh, I'm sorry. It is going to have to be adjust. So go ahead.
So like there where it says
I need justs on all these. You're right. Oh, that one doesn't need it, but this one.
It's like TA num underscore equals just int. Would we need one of those for booleans as well? So that when you call it, it would return just bool if you call it with a Boolean?
We don't have, I mean, if we added to our language something like, you know, a constant, let's say a true expression, then we could have an axiom like that. It could just say true expression just is always just bool. But we don't have any Boolean constants, but we have number constants, and they're just always ints. Does that make sense? There is no true or false in this little language, which is kind of annoying. I mean, what would you have to do? You know, you'd have to, like, for false, you'd have to say something like, and, or false, you could say like 1 equals 0. And for true, you could say 0 equals 0. Does that make sense? Here, I do need, I have been forgetting my justs on these.
So how is it when we call type check
Oh,
expression
and I'm sorry.
with like a type
Once-
assignment and a Boolean, how is it going to return like just bool?
How is what? Say it again. I'm sorry.
So if we were to call type check expression with a type assignment and a Boolean, how is it going to return just like
There
just
is
bool?
there is no constant of type Boolean. There's only you know, there's only expressions of type bool. Let me just fix this and I'll show you in just 1 second. Because this is a big issue. I'm like a major problem. And it shows you these justs are so annoying.
Oh, I have a question. Oh, wait, never mind.
Okay, and now, I don't know, what am I doing here? Oh, okay, I'm getting rid of that. A bunch of justs. So annoying. Now, I'm going to show you a trick in a second. Or when we're finished with this, we can do it in a different way. So was it Colton that was asking that question, or who was, Kyle, who was asking that question about a Boolean?
That was me. That's Colton.
Yeah, okay, so look, there is, you know, you could say, if you wanted to like type check true, and we could say TA0. So, I mean, I should probably call this now TA0 instead of T0. And I'll call, I don't know, should I bother? All right. Okay, then I guess let me just finish this. But what I was going to say is that you could type check with TA0 equals num0 num1, and that's going to type. So, all right. Yeah, that's going to type check to bool, right? What's the shortest thing that we can type check? That's going to evaluate to false, but it has type bool. That would return a bool. We don't have any constants of type bool. A constant is one up here in the data type that doesn't take any arguments. Now, num takes an int, but that's making a whole bunch of constants. I mean, we could say, we could say b bool, for example, and that would say, oh, okay, to get true, you write b true, and to get false, you write b false. Does that make sense? Here, you'd be adding two constants of type bool, and here you're adding, I mean, theoretically, an infinite number of constants of type int. Still confusing. If we had that b bool thing there, then we would have a case here right after num that says type check TA B don't care equals just bool. No, not doing it for you. So what's this one? It's TAE1, and it better be, they both better be ints. So that one doesn't count.
Actually, yeah, I'm pretty sure what you just added that returns the just bool would be appropriate.
That's what you were thinking.
Yeah.
We didn't have, there isn't one in the book though, because you can write for false, for example, this. And you can write for true equals num0, 0. But we don't actually have I don't know of a shorter way to write it down in this language than this. So this one is the same again, except that both arguments better be bool. Now this is really ugly code to me. And then it returns just bool because an and is a bool. So I would say that, I hate these. And this one could just be type check exp ta e1. Oh, we got to make sure it's a bool. All right, I'm finding this code really, really ugly, but let's see if it compiles. I hate throwing maybes in. Is anyone else?
Why do we have two minuses?
Two where? Did I?
One there and one at the bottom.
Oh, sorry. So we got and, all right, now we've got them all. Let's try saving it. And try, oops, I'm in the wrong directory, I think. Yeah. Quit. Okay. So now we can type check. An expression, and we could use TA0, which is the empty type assignment, to check, for example, num7. Okay, that's a just int. Good, that's what it should be. Now, what if I say, okay, update this one so that x gets the value int, and we're updating TA0, and then I see VX. That's an int. But if I said VY, I get back nothing. It's not well typed. So it's only well typed if it's in the type assignment. Now, we didn't do statements yet. But any questions about this?
Can I see and, how you did and real quick?
It just better be that they're both bools. And if it is, then this is a bool. Like, it doesn't make sense to say and one true or and true one. So to make sure this is well typed, what you want is you want E1 and E2 to be booleans. Now, in C, it's perfectly okay to say and one true because they interpret all non-zero values or non-null values to be true, and they interpret 0 to be false. So if you said, and 0 true, it's going to say it's well typed in that case. But for us, we're not allowing you to substitute numbers for Booleans. You got to put a Boolean in there. Okay? Now, I mean, I'm like really, though, want to fix this code. And one way to fix a bunch of these, well, there's a few different things you could do, but one way you could fix a bunch of these is I could have like, I could say, check for, and I'm looking for types. I want to check to see if this is an int, and then I want to have like an exp and an exp, and I want to return a maybe types. And so now I'm going to say like, okay, check for t e1 e2 is equal to, and now let me just grab, oh, I got to take the assignment too, so I got to have a an e. And so I could say check t1 t2 is equal to case type check exp e1. There might be a really nicer way to do this, but let's say type check e2 of just ty comma just ty arrow ty. Whoops, it's lowercase, isn't it? A t. And anything else, oh, it's a just, returns a just t. And otherwise it's nothing. And so then I could change all this code. This just becomes, oh, check for So down here, I say like, okay, for this one, it's a check for int E1, E2. Oh, lowercase. And now I can get rid of all this. Now this one becomes a check for int E1, E2. And now this one becomes a check for int E1, E2. Now, unfortunately, this one doesn't, I mean, I could say, I could do something, you know, to make the code more readable. I could say check for int. Oh no, it's always going to be a bool. I can't, my abstraction doesn't take care of that one yet, but let's see, maybe we can generalize it. But this one is, see, and this one doesn't match. So maybe I want to say, so all these are int. So, you know, I don't know. So this is more like an example of, you know, decent Haskell programming. I don't claim to be like the best, but now this one, it could be check for int bool E1, E2, or check for bool E1, E2. Oh boy, that the problem is this or doesn't work on here. There's a way to do it very elegantly. Oh God, is it? No. Oh God, I think I could do. All right, let's just see if we. The or is not going to work because these things are justs, right? And so, you know, I could make a pair here. All right. Well, this could freak you out. So it's not really probably the best piece of code, but I could say, no, that's not going to work. Does anyone see my problem here? Or does not work on, there's a very nice way to do this. And I guess I just kind of don't know it. So the or is not going to work on a main. Let's just finish the rest of them here. So now I'm checking on ints that will return a bool on this one. And this one doesn't work because it's not a pair. I mean, you could say, I mean, you could do this really dumb thing. I could say I'm checking for a bool, and I'm returning a bool, and I go E1, E1. That's really inefficient, but so I check it twice, but okay, I could still use my check for. And then here I'm checking bools for bools. So that made the program a lot simpler, except I still have this problem. Now, one way to fix it is to say, do T1 equals check for that, and T2 let's see if this loads. I'm not sure. All right, is everyone going to sleep on me? No. Oh, it's not a equal, it's a left arrow. Oh, those are going to come back as justs. Line 59. All right. These should be justs here. And then I can get rid of the, what did I just do down here? I broke something, didn't I? Line 59. Oh. I don't know. Is it a alignment problem? Oh, I see. I need to give, I forgot to give the environment here. The type assignment. Really?
I think on line 59, if you pull the justs out of that pair, it
Mm-hmm.
would be all right, because isn't it just gonna When you type
Well,
check it, it'll return a just value.
except that when I type check, it'll return a just value. And I want to match it against, I want them both to be, you know, like down here, int, 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 and then return bool, like in this one, int bool. So I'm giving the types, not the maybe types. I mean, maybe I should give the maybe types. Then I could write T, but then I have to write all these justs down here.
Are they supposed to both be T1s? Just T1 and just T1?
Yeah, I think all the cases that I see, everything is like, well, that we've erased it now, but all of them were, they either both have to be bools or they both have to be ints. Now, what I'm surprised about is, okay, I thought my error was going to be down in here, but let's see what's. Oh, am I not calling? I'm not passing TA to all these. And in fact, it probably really ought to be the first argument. So let's just see what happens. Sometimes it points to an error in a piece of code. So I would say TA is the first argument here. And then I can go down here and let's just fix this anyway. TA, TA, TA. TA, TA, TA. Oh, come on. What's this saying? Conflicting definitions. Oh, you know, one thing that often breaks me is, let me just comment this darn thing out. That didn't work. So you think, I don't see how I can just remove them because these are going to return justs. And T1 is simply something like enter bool. Oh, this is frustrating and, you know, embarrassing. I don't really want to deal with this long. I wanted to go on to the next one. But, all right.
Yeah, maybe since we're running a little low on time, we could look at statements.
Yeah, let's look at the statements. And maybe we can, you know, the other thing is we could go back up here and just say wrong. And now I don't need to deal with maybe. Get rid of that just. Get rid of that maybe. We'll just say wrong. And so then I don't have to worry about that. And I don't have to worry about that. I don't have to worry about that. And then I just say, in any other case, it's wrong. Oh, and this thing here should say the base T. This should say wrong. And now I can get rid of all these justs. I'm kind of liking this much better anyway. And then I don't need to deal with this. I just say, So what do I want to do here? I want to say you get back T1 comma T2, and then you just return that they're equal, but not wrong. Does that look better? That looks a lot better, doesn't it? We don't have all those darn maybes there. What a mistake doing maybes.
Can you scroll down real quick to just the equals again?
I'm sorry, I can't hear you, Jessa. You have to, you did something before and it was much better. Uh-oh, now I don't hear you at all.
Oh, I just wanted to see equals again.
See equals again.
Thank you.
But it's not liking it. Oh, I forgot the of. Oh, I know the problem here. You can't, this is a pattern match, and you can't pattern match on the left. So I could say, that's such a dumb mistake to make. So I got to say something like T is equals to T1. If T is equals to T1 and T prime equals T1, then T2, else wrong. Okay, we are getting a long time, but if that doesn't do it, we'll move on. Ah! Oh, right. Wait a minute. Oh. No? Why wouldn't that work? Come on, somebody must have a eye that can see this. This is a bool. Oh. But that should be okay. Where did I use this? Oh, line 67. I'm looking at the wrong line. Ah, thank God. All right. Okay. Now, let's go look at statements. Is that, are everyone okay with this?
Yeah, sure.
All right, let's look at statements. So now, I'm going to write a type check, STM, That's amazing. That's like magic. I used command line expansion and type ty, like expand whatever starts with a lowercase ty. Because it put this up there, it expanded to type check statement for me. So that was nice. So let's see. This is X and this is E1, let's say. And I'm going to need my TA, of course, everywhere. Don't need parens there. This is like S1 and S2. E. I could just call this one up here E. And S1, S2. And so then I've got a while E do S. Okay. So now, when is this well defined? When is this correctly typed as being okay as opposed to wrong? This one's just okay. Skip is always well typed statement. And this one we could use our check for, and we could say we're looking for using TA, we're looking for STM, STM, S1, S2. All right, so we'll leave the variable to the last. You might try looking it up in your book to see if you can get it. It's on page 192, type rules for bump, and it's the assignment. But let's do this one. I mean, you know, this could be like if, and now this is type check exp TAE is equals to bool then check for STM, STM, OTA, S1, S2, else wrong. Oh, that's a little tricky. Okay, so their statements. What about assignments? Somebody tell me, what do you got to do? Well, one thing is that the variable X better be defined. And let's say we only in this language, I mean, you could do it either way. I mean, he suggests that you could have Boolean variables, but then E would have to be a Boolean expression. So you could say something like, it's almost like the equals case, except that it's that X, this one has to be type check expression TAX and type check expression TAE, and that gives us back two types. And if they're equal, they have to either both be bool or they have to both be that, and else what do? Then I return T1. If T1's not equal to wrong. So this is a funny thing. You run across this in programming all the time, right? T1 is, if this is not false, then they're equal. So I could put T2 here. It's the same thing. Let's see if that works. Uh-oh. Oh, is it not called statement? What is it called? It's called STM.
I think it's because statement isn't a type.
I think it is, isn't it? Right here, data STM is a type, and those are the elements in it. I don't understand. Oh, I went way too far up. Okay, first of all, did I load the wrong thing? Let's see. BIM's type check. Okay, Control R colon L for me. Okay, 79. Oh, the check for thing may not work. Oh, did I put a?
In your types declaration, do you have to add statement to it?
No. It's not a type. The type is going to be either okay or wrong. STM is type. My problem is my check for thing is not polymorphic enough because I'm not able to figure out. I'm calling in, I can copy this. I can't use check for identically. I thought I might be able to get away with that, and I can't. So I'll say check for S, and so this has to be type check STM, and this has to be type check STM. And I might as well rename this S1 and S2 and call this S1 and S2. And either they're equal. Yeah. This is checking that they're both equal. And so now I got to go through here and change these to check for S. Now I'm still not really, I'm not completely happy about that, but it's not bad. Let's see if that works any better. Still have some errors, but hopefully I got rid of some of them.
I have a question.
Yeah.
So for if then else and while, so you're doing type check exp. Why are you doing type check exp instead of the statement one?
Because on the if then else, E has to be a Boolean statement.
Oh, okay, that makes sense. Thank you.
And then S1 and S2 have to be statements. But my check for S thing is not really working right, I don't think. What is it telling me? Line 81. How can that be wrong? Okay, so it's up in here. This just doesn't make sense. Did I not save it? Okay, now it's telling me line 82. All right, at least it's a different line, and it is one where I'm calling check for S. All right, well, time's up. I will get this working and I'll upload it to the modules section under today's lecture, the last lecture. I should have done this ahead of time, but I don't know. I have so many other things I'm doing as well. Sorry. Any questions?
So then after, oh, you go ahead.
Okay. So I just had a quick one. So I went to go turn in the homework and I don't see a submit.
Yeah, somebody else told me that and I forgot to fix it.
Okay, thank you.
My only question only was, so after we do the type check statement, we have to do the one for the declaration, right?
Right?
So there's just one more after the statement to do?
Yeah, we would have to do you have to do declarations, but I feel like I'm giving you all the code for the rest
Right.
of it. So, and the declaration is the hardest one to figure out, and there is an error in the declaration, but if you do it, the error is that when he's checking a procedure, declaration, he forgets to check that the body of the procedure is well formed. And so I can give you the rule on that, but if you've already, done it, don't worry about it. It's like he just left it completely out, which is, a huge error. Okay.
Okay, yeah, thank you.
All right. Any other questions? You're right. It's not a type. I got to say, okay, okay. Somebody tried to tell me, yeah, that's not right. But so this needs to be okay, okay. $78. Where is it thinking it's a list? Where's the list error coming in? I gotta say. Is it not var, the constructor? Is it v? V. Okay, there it is. So anybody else have any questions? No? I'm going to clean this up, though. I still feel like there's a much better way to do this check for thing. I'll think about it a little bit more. But, I mean, it's not terrible, but I don't like having two of them. I mean, this one, I don't like having the check for E, this will become, and the check for F's. But, okay. All right. If nobody has any questions, I'm going to get ready to take off. What's in the chat? I missed whatever Colton's comment was quite a long time ago. So any other thoughts?
No, thank you. Thanks.
All right. See you later. Bye. Andrew, you good? He just disappeared. Asher, you okay?